So section 2.4 is our last kind of look at different graphs, or at least in this chapter, right? So scatter plots, correlation, and regression. This is actually a huge idea. So we will touch on it a little now, but then we're going to learn about hypothesis testing in our last unit of this course, and then we'll cover this again. So we have to learn a little more to cover it completely. So the idea is relationship between two ideas. So a correlation is where you have two variables, and is there a correlation or a relationship between them? So is it true that the taller you are, the bigger your feet might be? Right? So is there a true correlation between that? Is there a correlation between how much you study and your grade in your course? Those are the type of things that we're going to look at for a scatter plot, correlation, and regression. We're basically just looking at linear, and a linear correlation is when the dots on the scatter plot are going to form a line. So remember, a scatter plot is each person goes over one and up, and that's their dot. So each study has two pieces of information. And then, so here's an example of what I mean by, each person's a dot, but every single data point on here is a waist and an arm on one person. So you can kind of see my scatter plots here with lots of data because each dot represents one person. So a scatter plot's pretty easy to do. You might have done it before in a different class, but you go over one variable, one variable up another variable. Usually we go X, Y, but we want to make sure we're labeling right so we don't have a graph that is misleading, right? Because it leave off titles for misleading graph. So if we look at this, these are some examples here. We can see that these form a line. It's not a super straight line, but it is definitely a line. As this one gets bigger, so does this one. They're both going up together. So that correlation would suggest a positive, and I would say it looks linear because it looks like a line. So here's the next one, weight versus your pulse rate. All right, here's the data, right? And it's not looking like a line. So definitely, it doesn't look like a curve either. It doesn't look like it's a pattern. So that means no correlation, no relationship. Okay. All right, here's another one that suggests a negative correlation. So as this one's getting bigger, I did not label these. That's because I had a hard time finding a negative one. So as this one goes bigger, they're going down for this one. So a negative relationship between X and Y. I did not label them on this. Notice it forms a really better line than like this one right here, right? This one, they're pretty spread out, whereas this one, they're pretty tight in that line. That makes a stronger correlation between X and Y. Okay. We could also have a pattern that's not linear. So this just says there are nonlinear ones, right? There are a lot, you could have a curve and it be an X squared. You could have something that goes up a little bit different and be an X to the third. So we just are looking at a linear correlation. So then we have the linear correlation coefficient R. So I'm going to highlight R. Oops, that's not my highlight. That was my erase button. So that R right there. We need to find R to help us with knowing if this is a better relationship than the 1, 2 above, right? That had a little bit more spread out. That will tell me. And we can find that in StatCrunch, and that correlation coefficient is it's just going to help me be able to tell which one is a better relationship. Okay. And then here's just for your notes, the closer R is to 1 or -1, the better the linear relationship is. So think of it like it's a percent. So if you get 0.99, you're almost 100% relationship. If you get 0.5, you're at 50% related. If you get a 0.02, you're at 2% related. Not very good. So, it kind of depends. So let me walk through, and then your regression line. Let me walk through how to do this on StatCrunch. Kind of gives you an example of the equation that you can write between those two, finding that slope and that y-intercept. But we need a little bit of data in order for me to show these. Oops. I guess one other thing, I do want to make sure this is kind of got bounced down. When I talk about a correlation, before I actually show you it on StatCrunch, when I talk about a correlation between two things, you need to be careful because a relationship doesn't mean one is causing the other to happen. Okay. So if I say studying more gets you a higher grade, one is not causing the other. We just have a relationship between them, showing the more you study, the higher your grade is. Okay. So we cannot say they cause each other. And we can't say that there is no correlation. We just say no linear correlation because it could have a different one. All right, so this first example I have only has 5 data points, so it's super easy for us to type in to somewhere for our data. So give me just a sec. So I am going to go into, maybe I'll do it this way. Aha, I just learned this. Chrome, where's my Chrome? So on an iPad, Google Chrome works pretty good in StatCrunch. Okay, so here's my password and username. Good. Okay, so this data is for question number 2. So I am going to put in the data we're looking at over here. So this is going to be shoe. So this is our shoe print. And this one here, I'm going to make height. Centimeters. Okay. Oops. I can't seem to get height in there. Okay. Shoe print. So this is going to be 29.7. And then the next one will be 29.7. And the next one will be 31.4. And the next one will be 31.8. And then the last one is 27.6. So you can pause and enter this into your StatCrunch too, or you can just watch me, but I want to make sure you know how to do this. So 175, 177.8 and 185.4. I like the split screen because I can see the data. I think that's kind of handy. Thanks, Jeff Walters, for showing me that. It's 175.3. And the last one, 172.7. Okay, so as long as I put that in right. So here's where we're going to go from here. I'm going to close that so we can just kind of see better. We're going to go to stat, and then we're going to go to regression. Okay, so this one's, the regression is right here. I can't really show it real well. Regression, there it goes. So mine will open below. On the computer, it opens on the other side. I don't think it's too bad. And we're doing simple linear. We're not going to do any of the other ones in this course. That'll be beyond our basic stats course. So then simple linear, and then you tell it where your X's are. So this is why I labeled mine. It was shoe print and height. And the rest we just leave and push compute. Okay, it gives us a lot of information here. So at the top here, it's giving us, I cannot point to it on this one. It's giving us where it says height 125.4. That is your B or your y-intercept plus 1.72 shoe. That's your equation of your line right there. And then it says your sample size was 5, so we only had 5 data. And then R, correlation coefficient, is what we are looking for, 0.59. Okay, so that's about a D on that relationship, right? The rest of the bottom part where it's talking about parameter estimates and things like that, those aren't things we're going to cover till later. So we only care about the top piece. And then look, I can arrow over on the top, it's blue. I can arrow over and get the scatter plot as well. So it shows shoe print height. Those are my 5 dots. They sort of form a line, but that's what you can see, that it's not that great of a line. Okay, so I can bounce between these two up here always. So one place in the regression under stats, simple linear, gets me everything I could be asked about a regression from StatCrunch. Okay, so I'm gonna look over here. It says use the following to find the R. Oh, what was the R on that one? I closed. There's my results. Simple linear. So over here, I'm going to type my R was 0.5913. Okay. My equation of my line is height equals 125 point, oops, I put a point before the 5 there. Don't really want to show that way. 125.4. I'll just go one decimal. It goes out a couple, but that's okay. 1.7. 3 if I go one more decimal, and then times that by shoe print, or we can call it P for print, X, Y, doesn't matter. But that's our equation of our line, our R. Our scatter plot's not too bad to draw. If we were going to sketch it for this one, it would look like, you can see it's going to be like this. So we had a dot here, dot, dot, and over here's a dot. You would have to label these, but that's what our scatter plot. So most of your homework will be multiple choice on that scatter plot. You can just match it to the StatCrunch. Okay, so we can see it's got a positive linear relationship on that one, and we can see that it's not the best relationship because R was about 0.59. Closer to 1, the better it is. Still's a relationship though. 0.59 is not that bad, just depends on your situation. Okay, so the next one. So we're going to do a little bit more of an analysis on this one, and it's a lot of data. So there's a link to the data here that you can either type in or click from the online version. So do freshmen in college really gain the freshman 15? Here's the data sets of weights in September and again in April of freshman college students. It's true data. Okay, I'm going to click this and it's going to open it in StatCrunch for me. And that was the part of the data that I'd already opened it to make sure it worked. Okay, so see, I put in quite a few data, or I stole this from StatCrunch's data sets, but there are 67 people in this study. So again, if I want to make the scatter plot, I could just go to graph and make a scatter plot, but I like that everything's in one place. So where did I go again for that? I went to stat, and then I went to regression. Stat, regression, simple linear. And my X values were the September and my Y's were April. We're going to compare our weights between the two. So here's our first part. So let me send this to StatCrunch or Notability real quick. See how that comes through. So I love Notability if you're using this kind of technology. Nope, it doesn't come through. Okay, cancel. Okay, so then from here, we can see that linear regression coefficient, the R, see where it says correlation coefficient? We can see that's 0.94. That is a super good relationship. We can see the equation of the line up there. It says April weight equals 5.04 whatever plus 0.9 times September. So you're timesing about 94% of your original weight and adding 5 pounds to get April's weight. So let's scroll over and look at the scatter plot. There's 67. That definitely is a pretty good linear relationship. It was 0.94. It's great. It's almost 1. And if it was negative, it would be like -94. And that would show a really strong negative relationship. That's why it says in your notes close to 1 or close to -1. So this is a pretty good relationship. So this equation of the line of best fit's pretty good. And you can see that people are gaining weight, right? So if I weighed 50, this is in kilograms, in September, I'm probably gonna weigh more. So It's like people are gaining weight. Are they gaining 15 pounds? I don't know. They call it the freshman 15. So if we bounce back into our notability, oh, our R value, gosh darn, I'll just open it right here too, because I don't know if I remember all that. So the R value to write on your note packet here was they have it as capital R, but it's the 0.9 4-ish. Okay. The equation of the line is April's weight equals 5-ish point, I don't know, 0.4. Oh, that would be a 5.05 if I round 2 decimal places, plus 0.94 for 2 decimal places times September. Ooh, it changed that on May 9th. Let me rewrite that piece there. Times September, however you want to think of that. Okay, so review your R and your scatter plot. And looking at them both, do you really think people gaining weight is happening? I do from that data. Definitely looked super strong relationship. And this is in kilograms, but still, like if I started out at 70, let's see what it says. So if I started out at 70 in September, I'd go 0.94 times 70 plus 5.05, and I would be at 70.85. So I'm definitely gaining weight. Is it quite 15? Well, we're not even in pounds, so kilograms, because this is just the way the data went. So I don't know about the freshman 15, if we're really showing you're gaining 15 pounds, but it is positive. So people are gaining weight. But I don't know that you can actually say that they're gaining 15 pounds because it's not in pounds. And yeah. So I know that's probably not the best example, but I liked the freshman, and they called it the freshman 15, even though it's in kilograms. I could have moved them all to weights, so it'd make a little more sense for us, but I think you get the point. So the big takeaway on this section really is just, does it form a line on your scatter plot? You go back up to these scatter plots. Does it look positive, or does it look negative? And or does it look like nothing, like this one, kind of crazy? And then just looking at R and deciding if it is a strong linear relationship based off that. So that's all. You don't have a whole lot of questions on this section because, again, we revisit it again later.